Hi, y'all. I'm Shai. Really happy to be here to chat with y'all today. So let me set some context for y'all. This year, I would argue, is the big year that AI has moved on from this experimental thing to now it's in production. People are using it. It's no longer experimental. It's essential infrastructure, right? It's a core part of everything that we're building. KPMG estimated that agentic AI is going to lead to productivity gains of $3 trillion annually. And financial services is at the forefront when it comes to AI adoption. I want to give you some overviews of a report that we actually just posted on the Temporal blog. So this is hot off the presses here. We sent out a survey to a bunch of different engineering teams, and let me give you context for who those engineering teams are, so you can put this in the right light. We surveyed 153 engineering teams, so founders, engineers, architects, and other roles. We had a whole host of different industries that we reached out to, 21% of which were financial services. So financial services were at the top of that survey across all sorts of different regions, 70% from North America, and then Europe and Asia Pacific, and of a bunch of different organizational sizes. So it's a pretty varied sample of data. And like I said, the people leading AI adoption in our survey are banks and financial institutions. They are some of the most represented people and aggressive AI adopters out there. But there's a problem, right? There's this huge gap when it comes to taking a really cool prototype and getting it into a production system. It's really easy to build an AI. Building an AI agent has literally never been easier. But reliability, especially in production, that's still a very scary story. You might have made a really cool AI agent demo, and your leadership is thrilled. Let's go do this. Let's go ship this. And you put it into production and everything breaks, right? You scaling up from that one use case on your laptop to production level systems with millions of people hitting it at the same time, that's really hard. Everything just starts falling apart. And so the reality is that today's AI tooling is really, really good when it comes to prototyping, but it makes production deployments basically impossible. And so in our survey, we found that there's a systemic reliability crisis going on with AI. Half of the teams that we talked to are still experimenting or prototyping their usage of AI. 38% of them would say that they are at a mature adoption, that AI is essential to their business, or they're scaling it up internally. But even those teams that have AI in production lack confidence in their systems. So let's talk about that. Only 13% of the people that responded to our survey feel very confident when it comes to debugging AI at scale. 60% of the people that responded to us responded as neutral or worse when it comes to their confidence in AI. And without confidence, you can't scale, right? And without scale, you can't deliver that $3 trillion of productivity value. And then there's a lot of cost associated with those reliability issues. 62% of the teams that we talked to lost measurable time or revenue because of reliability issues. That could have been anywhere from 10 to 50 hours lost, developer hours per year. That could have been anywhere from $1,000 to $10,000 in direct annual loss. Some lost 200 plus hours or even $100,000 plus annually. And you might be wondering, how often are these failures happening? So we can take a look at the frequency. 30% of them responded and let us know that they were having failure every week on a weekly basis. 34% of our respondents let us know that they were facing issues monthly. 64% of them said that they just face regular failures. So that's 2/3 of engineering teams that we surveyed dealing with failures regularly. And let me give you a quick graph of that statistic that our respondents gave us as well. And then even then, they were getting very specific failures. So let's talk about the ways that AI is failing. There's a bunch of different failure patterns. So 55% of them told us that the LLMs being inconsistent was the most fragile part of their system. So getting different responses back from the LLM. 45% were struggling with long-running workflows. I don't know if anyone's ever used Claude and you hit the point where it needs to compact your chat and you have to wait about a minute because you've been going so long and it needs to resync the memory. 45% were just experiencing agent failure. 41% had like service coordination problems, so coordinating between different tools and different services. 39% just felt like they didn't have the observability or the debugging capabilities that they needed to be successful. And so there's a whole lot of reasons why AI is really, really hard to get into that production system. So let's dive into a quick financial services example. Let me make it concrete for you with a financial use case. So I want to talk about loan origination. So loan origination, I think, is a really good example of a long-running AI workflow. So with a loan, we've got a bunch of different steps. It's a 6-step workflow. I grabbed a screenshot from the Temporal UI of those 6 steps, from like the application to the decision, and we'll go into these steps a little further into the deck. But essentially, the main thing to keep in mind is that these workflows, they could take a couple different days to complete. They're going to need to coordinate between all sorts of different systems, credit bureaus, verification services, risk assessment system, all sorts of different stuff. We've got all sorts of different stakeholders here. We've got AI agents that are going to be involved, maybe for document verification. There's going to be a human underwriter reviewing things. You've got compliance officers. You've got the person who's requesting the loan. And every step is a potential failure point. And this is why I like working in financial services, is because like every single one of those steps is like hugely risky, and like the fragility of it is really, really high. So what happens when something fails? So let me walk you through a concrete failure sample. So we talked about validating our application. An agent's going to validate that, check for completeness. Cool, it worked. We're going to hit a credit bureau API, maybe an Equifax or something, get our credit score. That worked. We do an income verification, probably some third-party service to figure out that they actually make what they say they're making. We do our analysis. An AI could upload or analyze these documents, make sure that they're valid, make sure the driver's license looks real. And then we ask our AI agent to do the risk assessment, and it's a complex calculation, right? Like it's a really tricky calculation with all of those previous steps, and we get a crash. Okay, so whatever reason that crash is, let's say our pod has an out-of-memory error and it's been killed, so like memory pressure has caused our node container to shut down or whatever. Traditionally, in standard architecture, what would happen is we would cascade from that crash to a manual intervention. And every step in that process is going to make it worse to debug. The further on we are into that process, the harder it is going to be to resolve it. We're going to lose all of our state. We crash on step 5, and we've lost everything from step 1 to step 5 by default if we've built it that way, or if we didn't do anything extra to add the resiliency. And so our agent doesn't know what work was completed when we try to rerun it at step 5. Something I think that's worth throwing is like asking, showing that survey of like how people actually typically resolve stuff. And 41% of the people that we spoke to leverage like built-in retry or fallback logic. And these are all temporal using folks that we reached out to. 40% of people are recovering manually as well. But so there's still like a lot of human time being spent on this stuff. 40% of failure requires manual recovery by an engineer. That's where that time loss is coming from. And this isn't a rare scenario. It's a normal scenario. This is how production AI is currently working in industry today. So let's go into the root cause here. State management across distributed systems is really hard. It's like a fundamental challenge to building these services. And 27% of the people that we reached out to explicitly called state management as like a fragile point of failure. And state management issues showing up in LLMs results in inconsistencies, it results in really long workflows, and then just those agents themselves failing. AI is really smart, right? Like it's really powerful with the reasoning capabilities that we get through LLM, but it doesn't really have a backbone or a spine, right? Like it lacks the reliability of orchestration and like of state management. And I want to say, what if there was a fundamentally different approach to building these systems? And the solution I have is durable execution. So durable execution is a crash-proof execution that guarantees that your code runs to completion. So the core guarantee of your code, if it doesn't run to completion, you are getting a clear error. You're not getting any silent failures. You're not losing state. that it can survive a crash. If a process crashes, your workflow is going to transparently resume in a new process. It's going to maintain your application state automatically. It's going to preserve it, and it's going to restore it. And all of that progress is going to be maintained, so you're never going to lose completed work. If you get to step 5 and you fail on step 5, step 1 through step 4 are still there. And so let me show you how this works within Temporal. So this is a screenshot, like I said, from the Temporal UI. You can see each of those steps that we had. Each of those steps there is a discrete activity in this workflow. Every function call, every decision, every API response is being recorded by Temporal here. And when we're replaying our completed steps, we're able to inject the previous results from our history, from our last success state, into the retry attempt of the failure. So we're able to rebuild our application state exactly as it was before whatever happened crashed. And then we can continue our execution from where we left off, as if the crash essentially never happened. So let's talk about the loan origination process, that crash. What would happen if this was implemented with durable execution using Temporal? So the durable execution model would automatically recover, replay that history, and then resume seamlessly, like nothing ever happened. If we had a crash, we'd just get it grabbed by a new worker. That new worker would just automatically pick up that workflow and keep going. It would maintain steps 1 through 4, so it would replay that event history. No actual rerunning or repeat computation needed. All our variables, all our data, all our state is going to be restored to the exact point of failure. And execution is just going to keep going at step 5. And the customer is never going to know anything happened. From their perspective, the application process just was smooth and didn't really need anything at all. We didn't lose any data. There was no duplicate work, and we didn't need any manual intervention here. Here's kind of a quick example of what a production-ready AI stack would look like. Layer 1 is our AI agent, our LLM that's making calls, making our decisions. It's got our business logic. And then we have our durable execution engine. That's going to handle state. It's going to retry. It's going to recover for you. And then you're going to have observability. Temporal integrates really cleanly into Datadog, and we've got support for all sorts of different open telemetry endpoints. So you can monitor anything, you can trace things, you can analyze every single execution. And that's going to result in real-world success. And we're seeing this out in the field with some of our customers. So Replit is a $20 million developer-strong coding tool with AI agents. And they were struggling with just a ton of demand. Their agent adoption was surging, but they were running out of memory. Their provider outages were threatening the UX and the experience. And so they migrated to Temporal Cloud. Now every agent of theirs runs inside its own workflow. And that migration took took weeks for them, not months. It eliminated a lot of edge cases for them. And we got this great quote that it's pretty bad UX to have the agent get far into something, hit an error, lose everything, and then have to restart. ZoomInfo is another customer that we worked with, B2B data intelligence. They process millions of signals daily, and their pipelines were really brittle. They were having batch delays. It made it really hard to do real-time personalization. And so, again, they moved over to Temporal Cloud to get that durable execution layer to orchestrate their workflows reliably, and they managed to drop their lag from hours to seconds. And so they were able to get to the point where they were able to do personalization, which I think is really great. And Frank, gave us a really great quote that they were able to scale things up, and Temporal has never been their bottleneck. And Georges, which is an AI-powered help desk for e-commerce, had really long problems when it came to long-running conversations with an LLM. The LLM would hallucinate, or the APIs would tie out, or it was a big problem. And so now every AI conversation is a temporal workflow, and those agents can handle multi-step issues without manual intervention. If there's a failure, it's still maintaining all that state, so that agent can go back and look at what's happened, and their customers are going to see faster resolutions because of that. And that workflow approach was really good for them because at the end of the day, all LLM use cases are workflows. So these teams were able to give their AI that backbone with durable execution. So looking forward, what does the future hold? 88% expect to at least moderately boost efficiency or revenue in the next 12 to 24 months. 54% of the teams that we talked to expect a significant or transformative impact from AI. These teams are prioritizing a bunch of different stuff. So let's talk about what they told us they're thinking about in the next 2 years. 63% of those teams told us that reliability and failure recovery is the most crucial thing when it comes to building production AI systems. 52% of them told us that observability and debugging was important. 48% of them told us that infrastructure needed to be more cost-effective and efficient. And then the teams, know what they need. They need reliability, observability, and fault tolerance. So not just better models, but all the things that are running those models need to be better. So better infrastructures. So let me do a quick summary, and I'll just whiz through this since I'm over time. AI is essential. It's not going anywhere. 38% of enterprises using AI. Confidence is low. 13% of the teams we talk to feel confident using AI in production. 64% of the teams that we talk to are facing monthly or weekly failures. 62% of them are losing measurable time or revenue to reliability issues. And state management in distributed systems is really, really hard. And durable execution, helps solve that problem. It gives the backbone that AI needs to be successful. With those 3 layers of AI agents, durable execution, and observability, we're able to get to a production-ready AI state and see real teams succeeding. Yeah, and don't let your AI be all brain with no backbone. And if you want to learn more about durable execution or see the full 30 or 20-ish page document that we released of this survey, you can just head over to temporal.io to view that full report and check out our documentation and learn how to get started. Thanks, everyone. Appreciate your time.